Hello, thank you for joining us today for the AWWA webinar on the top 3 steps to reducing non-revenue water, sponsored by Census. I'm Lauren Wasserstrom, Associate Engineer at AWWA, and I will be the moderator for today's webinar. Here are some tips to enhance your webinar experience. We recommend you close email instant messengers and any other programs not currently in use, as they may interfere with the smooth reception of the webinar, causing slide buffering and poor sound quality. Technical assistance can be found at the GoToWebinar technical support page at the link listed in your handouts and on the slide shown. As soon as you close the GoToWebinar screen to leave the webinar, a window will open with a survey questionnaire. We ask that all of you take a few minutes to answer the survey questions. Your feedback is important to us and helps us improve webinar programming. We encourage group participants to pick one person to enter collective responses to the survey and submit them to us. Before we hear from our speakers, I need to inform you that the mention of specific products or services in this webinar does not represent AWWA endorsement. AWWA does not endorse or approve products or services. I'm pleased to introduce our experts for today's program. First, we have Travis Smith, Senior Product Manager for Water Metering at Census. Travis has over 20 years of experience in the water and wastewater markets, including treatment plant design, project management, chemical handling, controls and instrumentation, operations efficiency, and communication systems. Travis has a Bachelor's of Science degree in Mechanical Engineering from North Carolina State University. We're also fortunate to have Avery Lunsford, Conservation Manager at City of Universal City, Texas. Avery has worked for the City of Universal City for over 20 years, starting as a public works field serviceman and moving through the ranks to conservation positions and utility administrator during that time. Avery will be sharing some of the water management issues they faced over the last few years and how they are making improvements in their water conservation program. In our webinar today, we'll examine how to identify the source of non-revenue water. From water audits to usage analysis, utilities need to first understand how their water system is performing and the source of any lost water. We'll also discuss what controls will minimize or stop leaks. Universal City will share their success stories to manage pressure, detect leaks, measure flow, manage tampering, and more. And lastly, we'll examine why ongoing management of the water system is critical. We'll look at real-life results and the necessary steps to ensuring the health of the system. Our panel will be happy to answer your questions. Feel free to submit any questions throughout this broadcast by using the question pane at the lower right of your screen. Please include your name, city where you are viewing the webinar, and the name of the panelist to whom your questions should be directed. So to begin the webinar, I'm happy to turn things over to Travis Smith at Census.
Thank you, Lauren, for that introduction. I appreciate the opportunity to share with all the attendees some of the information around non-revenue water. So as we look, water is one of our finite resources in North America, and typically a lot of utilities have over 20% water loss through those operations of delivering their water, which is a significant encumbrance because we spend a lot of time, manpower, energy, chemicals to obtain the water, to clean it, and distribute it. So finding ways to reduce non-revenue water helps us improve the sustainability of that clean water and the supply to all of our constituents, conserving energy, and the reduction of production costs associated with the water. Going through today, we'll break down the non-revenue water, how we look at all of the components of that, the sources of non-revenue water, how to monitor non-revenue water, and then finally reducing non-revenue water. And then we lastly leave you with 3 easy-to-take steps to reduce that non-revenue water component within your utility. So if we move to the census water balance, and this is mostly based on the AWWA methodology, looking at all of the water into the system versus how it is consumed, used, and distributed or lost throughout that system. And we'll break this down in several components. The first being the water balance inputs. So we obtain water from surface water plants, groundwater, or even purchased water from other neighboring utilities. Those 3 components comprise the total system water input. From there, the water is either consumed in an authorized manner or considered a loss. And we'll further break down those pieces going forward. So looking into the authorized consumption component of it, typically those pieces are two use types: billed and collected meter use, billed and collected unmetered use. So the first, as the most common usage would be either we transferred it to another municipality and sold it there. It was used in some sort of residential consumption or commercial, industrial. But important to note there that any leaks associated with after a meter would be accounted for here as revenue water. We could also have billed and collected unmetered use where there's flat fee structures, thus making it difficult to totally account for the entire flow associated with that portion of revenue water. Moving forward into some authorized consumption, but also unbilled portion of that. So an important distinction to us is here in the purple box, where we actually billed for the water consumption, but we're not able to collect the funds associated with that consumption. So it's lost, it has to be written off by the utilities as non-collected payments. Then there is also unbilled authorized consumption, breaking down into both unbilled metered use, and an example would that be of something that is a billing error, city use, other authorized non-payments, could be flushing within a utility. And then unbilled and unmetered use. Again, city usage might be unmetered, flushing might be unmetered as well. So all of those components comprise of the unbilled authorized consumption portion of the water balance. Moving forward to the loss piece, we break down the losses into several different groups. Unauthorized use, such as thefts, illegal taps, or tampering with the meters, comprise of a portion of non-revenue water. And then second of apparent losses is metering inaccuracies, where we're not actually accounting for all of the water that is consumed and used for commercial, industrial, residential use. That could also be attributed to some sort of tampering associated with the meter or age of the meter, some opportunity for us to account for that water going forward. And the last part of the water balance are the real losses. And we look at those in terms of three distinct use types: leaks on transmission and distribution lines, leaks on service connections up to the customer meters, and then storage tanks, leaks, and overflows. And those all comprise of non-revenue water as well. So bringing that together, that brings us into a complete picture of all of the water coming into the distribution system, less all of the water that it was consumed or transferred, billed, used, or unaccounted for in some other methodology, to bring together the total water balance of each individual utility. So if we look forward into how to monitor the non-revenue water, many of you use different methodologies today. The most common one is to monitor the produced versus sold methodology, where we know all of the water that is put into the system and ideally all of the water that's sold, leaving us some portion of non-revenue water, but doesn't really break it down into the same granular categories there. So can you break that down further into apparent losses versus real losses, trying to attribute to things such as theft, tamper, or meter inaccuracies? Thirdly, importantly, is how accurate is the information? Is the information conveyed to us where it is reliable, dependable? Are there meter inaccuracies? Things that we need to account for or adjust to close that water balance to make sure we are accounting for all of our water through the process appropriately. And then lastly, what procedures are in place to correct or adjust all of the areas where we attribute either revenue or non-revenue water? If we go forward and continue to look at these things, we look at two specific cycles associated with non-revenue water. So starting with item number one, as non-revenue water increases, the costs of operation increase. These costs further rise and increase in capital expense to meet the demand of additional supply within a distribution system. And that goes to item 4, where budgets are decreased, restricting corrective actions to reduce non-revenue water. This forms a vicious cycle, further constraining our ability to recover from all of the non-revenue water activities within a utility. The opportunity for us to change from a vicious cycle into a virtuous cycle starts with non-revenue water decreasing, which then increases our revenues and decreases our operational costs, thus providing deferment of capital spending for supply increases. Then that creates funding, which is available to invest in additional non-revenue water. So as we begin to break that vicious cycle into where we recover that non-revenue water, we capture additional funds to improve the utility's operation and find new methodologies and funding available to find more of the non-revenue portion. So as we begin to look at monitoring all of the non-revenue water, I want to focus a little bit on different types there as we look at each specific category. And the first is starting with billed non-collected meter use, something that is faced in all utilities where we have to write off the amount of money that we actually spend all the time to produce, send it to a consumer, send the bill, and then not collect the payment. Some utilities, this can be a significant factor, anywhere from 5 to 10% of their actual utility payments, and frequently numbering over $100,000 a year. Often the utilities would have to bear the cost of expensive truck rolls and then the labor associated with those truck rolls. Could we use that labor to find higher value leaks or repair the leaks, thus helping us break that vicious cycle of non-revenue water? As further technology becomes apparent and available to all the utilities, remote shutoff valves alleviate and provide an opportunity for utilities to capture that and mitigate that situation of non-collected payments faster to save more time and money for those utilities. Smart meters and AMI systems that report on an hourly basis can certainly find leaks and reduce leak adjustments to all utilities going forward, which often contributes to a high volume of the non-collected or write-offs associated with the billing activities. With the new smart meters, most of them include improved data logs for dispute resolution as well to help further enhance the collections and disputes associated with either leaks or non-payment activities. If we look at authorized non-revenue water, where it's unbilled metered use or unbilled and unmetered, things of city buildings, flushing, city parks, the easiest thing to do is to capture that consumption by using meters so that it is accounted for in the balance, even if it is not billed. That way it helps us understand exactly where all of that consumption is. Could also help us find additional usage or conservation methods going forward associated with those portions of the consumption. Moving on to theft, an unpopular topic for all utilities, but certainly something that occurs in many municipalities. Smart meters and smart devices can certainly detect tamper, empty pipes, or reverse flows associated with theft activities. An AMI system will help all utilities monitor those activities faster to get hourly reads, daily reads associated with any of the activities within the service connections. Additionally, many AMI providers are coming out with fire hydrant monitors to monitor consumption and use inside of those units. If there was any distribution that was unauthorized from there, it could be detected quickly. In an AMI system, you would get that notification possibly within time to take action and correct the activity. Utilizing analytics associated with an AMI system can help find that. You see examples here of tamper alarms that would be broadcast almost immediately for any utility to take action to preserve any loss activities or unauthorized use reduction going forward. In terms of meter inaccuracies, this is one of the easiest ways for a utility to capture a large portion of non-revenue. As mechanical meters get older, there is frequently frequently a drift in accuracy that can be a substantial loss. Some of those meters have 10% or greater inaccuracy due to wear and age. The opportunity for utilities to invest in both solid state and long-lasting meters to provide extensive accuracy with the flow usually has a very attractive return on investment. And we do encourage anyone to start testing programs, particularly around the large meters, as they tend to represent a significant portion of the distribution consumption, and they're easy to test. They typically require field testing versus replacement of residential meters, which is simply distribution of more units out to the field. But a testing program can find a significant amount of actual flow that was consumption and raising your revenue to reduce that non-revenue water component associated with the water balance. If we look at real losses, the leaks, obviously something that we want to improve and avoid in all utilities. Typically, the easiest way to find the leaks is to attribute more data throughout your entire distribution system, whether that is smart meters, pressure monitors, or additional devices that pick up the sensors of tanks and overflow consumption within the distribution system. Additionally, acoustical monitoring can be deployed on many AMI systems to detect where the leak might be, so that it gives you the opportunity to look at all the 4 stages of the leak, and that is awareness of, do I have the leak and how big is it, and then locating the leak with the use of pressure or smart meters or acoustical monitoring, and then deciding to take action, and then most importantly, verifying the leak quotient has been changed and we have a true improvement in the system and reduction of those real losses. And this can be used for many, many types of leaks, whether they're in the distribution mains or in the service connections, or whether they're just tanks overflow leaks as well. On top of many of these things, you can use analytics to track the data, and we encourage you to utilize that at an hourly basis, because the diurnal use pattern within a utility system does vary by time of day, and monitoring things such as pressure and acoustical monitoring over that entire use pattern gives you a lot more intelligence to find the leaks. You see there examples of leaks detected through an AMI system, either meter or actual acoustic monitoring. I think Avery will share more about that as his experience going forward in the rest of the presentation. Additionally, in looking at the real losses, you can attribute specific hourly consumption data, whether that is patterned use or continual leak data associated with real losses, to understand, is it consumption or leaks associated with distribution of the water. Another way to help find and identify real losses is to deploy a district metering area program, where you break down your service area into smaller, easily tracked zones, so you can focus either on older parts or areas that you either suspect or know that you have a higher leakage rate within your distribution system. Utilizing a master meter or virtual meter inside of those zones to account for the water may allow you to progressively and find the leaks and then stage that out over time to grow, instead of trying to take down the entire process in one calendar year. So the use of district meters does help us find and break down that system. Additionally, the use of pressure associated with the entire distribution system, where you could look at a pressure profile of what the actions are with respect to flow as that pressure changes, as flow consumed or the amount of water consumption rises or lowers, would be a great way to identify a leak within the distribution system. If the flow is actually reduced and the pressure does not increase, typically that is an indicator of a leak, and you can use this to both reduce or to identify the leaks and reduce and control the pressure within the system, as pressure is significantly one of the components of a distribution system that helps cause leaks, and is the easiest way to reduce the leaks if we're able to reduce the pressure within the system to minimize the leaks in the lower usage times of a water distribution system. You'll see that here on the next chart. By simply reducing the pressure, you can reduce the amount of leakage through a known hole in a significant pattern going forward. So there's some opportunities within a distribution system just by reducing the pressure to reduce the amount of loss within that distribution system. So if we try to summarize all of those things, the easiest three ways to capture more revenue, and you can grow into this over time, but as you start to break that vicious cycle and enter into a virtuous cycle, by doing three simple steps such as ensuring your meter accuracy, creating some sort of testing program to make sure that you're accounting for all of the consumption that is delivered, is an easy way to identify and capture the most amount of your water balance that is already available and is not really necessarily a real loss. But to help find more of the real losses, though, capturing more data either to account for all of the areas of the water balance, so you're breaking down each of the components that we shared today, helps identify which pieces are being used and which are being accounted for. And that does go consistently with both measuring pressure and consumption and acoustical monitoring within the system. So the more intelligence you can put into your distribution system and capture more data, the more likely you are to raise your awareness, your accuracy, and your location associated with those leaks. In order to do that, typically you need to analyze frequently the data available to you. So the best way to identify a leak is to baseline the data, review over an hourly basis of the consumption pattern associated with your utility, and utilize programs available such as the AWWA free water audit software is available to all water utilities to help close that balance. The same information we provided today is analogous to that software that is available for everyone's use going forward. So if we look at that, we encourage each of you to follow through your own water balance, the census water balance, or the AWWA water balance to identify each of the components within your utility, whether they are authorized, consumption, or they are non-revenue water pieces, to begin to count that and start the virtuous cycle of improvement within your distribution system. And I want to leave everyone here with a reminder of why we're all here, and that's to leave the clean water available for the future, whether that's energy consumption or distribution of fire safety or clean water for public safety and health for all of the citizens to come, yet is our primary purpose. With that, that's all I had today. I'll turn it over to Avery Lunsford of the City of Universal Cities to share with us his experience going forward.
All right. Thanks, Travis. I guess we can go to the next
Avery?
slide. Yes, hi. Can you hear me now? Can you hear me, Travis?
I can. Go ahead.
Okay. All right. Good morning or afternoon, depending on where you're at. My name is Avery Lunsford, and I am the Conservation Coordinator for the City of Universal City, Texas. Next, please. Universal City is located just outside of San Antonio. We have a population of about 19,000. Currently, we have a total of 5,999 metered connections with approximately 75 miles of water mains, covering an area of about 5.6 square miles. Our primary source is groundwater supplied from the Edwards Aquifer, with a supplemental supply of Carrizo Aquifer water provided by an interconnect with the Shirt-Seguin local government cooperative. For those not familiar with this part of Texas, we've been struggling with drought conditions for several years. Pumping restrictions imposed by the Edwards Aquifer Authority have been in place every year since 2010, which has reduced our pumping limit by significant amounts. So needless to say, water conservation is a very important aspect of our long-term water planning. With the Census FlexNet Advanced Metering Infrastructure, or AMI system, becoming operational, the city realized an opportunity to implement a leak detection program that could cover the entire distribution system using leak noise or acoustic noise loggers. It was hoped that with this technology, it would be possible to audit the water system on a daily basis and address leaks before they would normally manifest otherwise. With the AMI system already in place, the water utilities would have to come up with the funds to purchase the loggers and transmitters. So the city approached the Edwards Aquifer Authority in the hopes of obtaining funding for this project. Hey, Travis, could you go ahead? Okay, go back to slide 36 if you could, Travis. Thanks. The Edwards Aquifer Authority is always on the lookout for new and innovative methods to conserve water. When the city approached the authority with the idea of instituting a system-wide leak detection program, they were very receptive to the idea. So in 2010, the Edwards Aquifer awarded the initial grant funding to begin the city's Permalug Plus AMI leak detection program. The scope of the program included 375 FCS acoustic monitoring devices called permaloggers. The project was phased in over a period of 3 years. The schedule was 125 loggers per phase. We began the project in 2011 and finished it in 2013. Next, please. The completion of the project made Universal City the first complete monitoring system, basically would monitor our distribution system to meter end user in the Edwards Aquifer region. At the same time we were installing the loggers, the city also replaced all water meters in the distribution system. At that time, the total was 5,784 meters, ranging in size from 5/8 inch to 10 inch. These included iPearl, SR2, and Census Omnis. How the logger system work, or the loggers work, the loggers themselves are placed on an inline valve operating nut connected to a Census FlexNet radio transceiver attached to the valve stack cap. The logger itself will turn on at 2 a.m. every morning and listen to the line. If the logger thinks it hears a leak, it will listen for it again a short time later in order to verify. After that, all loggers in the morning will report through the Census FlexNet AMI system. If a possible leak is detected, it will transmit this information, and then we would assign a utility crew to the location in order to determine if in fact there's a leak and make the necessary repairs. Next, please. The city had immediate success in locating leaks, some that had troubled us for years, and some that would have gone on for a very long time before being discovered. One of the most significant ones was in a location called the North Lake Business Park. There was a storm drain at the end of North Lake, which always had water coming out of it. At first, we thought it was infiltration from a natural spring in the area. However, the flow was constant, even in times of no rainfall and lowered water tables. The city tried for years to locate the sources of the water. At one time, we even called in the San Antonio Water System leak detection team, which proved fruitless for us. When the first phase of our logger program was brought online, this area is one of the first locations to be monitored. Within the first couple of days of monitoring the area, we received feedback from the loggers that a leak was detected at a dead-end main. The culprit turned out to be a section of main that was thought to be abandoned. The leaking section of main intersected the underground storm drain, but instead of showing up at the place of the leak, it was traveling upstream, or kind of I guess you could say uphill, and infiltrating at a pipe joint about 100 feet away. This is basically explains why we had no luck before of actually finding it. We were looking in the wrong place. So when we were able to locate that one, that was a big one, because that had troubled us for years, and we leaked a lot of water, bled a lot of water out of that leak. There was another occasion. There was a shopping center alleyway which had a water main running behind two business strip centers, with a sanitary sewer servicing the strip center running parallel to the water main, separated by about 8 feet. We received notification of a very strong leak in that area. When we showed up at that location, we were expecting to find water flowing down the alleyway. We got there, we saw nothing but dry ground. We went ahead and dug a few feet upstream and downstream from where the valve was located. They had the logger, but with actually absolutely no indications of a leak. We scratched our heads for a while. You know, we didn't know what we thought. Maybe we had a malfunctioning logger. We decided to check the manhole to be sure that we weren't getting some kind of corruption from a leaking or a flowing manhole. So we popped the lid, and we actually saw water running down the side walls of the manhole. We dug out from there and realized that the leak had traveled from basically a few feet away from that manhole, which traveled underground along the manhole and into the manhole itself, which never would have manifested itself. We were able to locate that one and repair that pretty quickly. That one would have gone on for quite a while if we hadn't. The final one was actually, it's a very odd situation. Springwood subdivision. We received a call from a resident who complained they had water pouring up from an area around their sewer cleanout in their front yard. The home was at the bottom of the hill in a cul-de-sac. So we checked our sewer main to see if there was a backup. It was flowing fine. In fact, the customer's sewer lateral was clear as well. We did a fluoride residual check and determined that it was treated water and not from any springs or any kind of infiltration in the area. The customer's meter had no movement, and neither did any of the neighbors. That would indicate a leak, on their side. We decided to check to see if any loggers in the area would show indications of a water leak. The closest location, or logger to this location, was approximately 200 yards uphill from the home on a cross street. We were able to locate the leak and made the necessary repairs to the water main. Of course, once we repaired the main, the homeowner had no more water flowing into the yard. What we were able to determine was that the water from the main leak had flowed down the hill along underground, underneath the path of the sanitary sewer main. And once it reached the bottom of the hill, it took a turn and followed the customer's sewer lateral right up into the front yard. That was another one that it helped us immensely to locate that leak that was troubling this resident of ours. Basically, since we switched to the AMI system, which included replacing all water meters throughout the system, we've seen a substantial drop in non-revenue water. We have gone from an 8 to 10% to approximately 4 to 5% difference between total water production and total metered use. We attribute a lot of this to the Census AMI system. We are getting a far more accurate accounting of water delivered to our customers, and we're able to address leaks in the system before they would manifest on the surface. Next, please. Since we've been using Permalog AMI leak detection system, it has evolved to incorporate work order management. The city partnered with Aquametric to support the Permalog leak detection program by taking the data generated by loggers through the Census FlexNet system to be displayed in an online application called Nova Center. Using this application, when a leak is detected or if a logger is not reporting, we can issue a work order and have it sent to the utility serviceman's electronic tablet. Once the work order is complete, the serviceman uploads his findings and action taken. We are notified back at the office about what's going on. Nova Center is the asset management software that gives us the ability to combine asset tracking, near real-time reading from the devices in the field with GIS functionality. It provides the following. We can monitor and it reports real-time information on geographically dispersed assets and intelligent devices. You can even incorporate meters into this. And it captures and presents information in different forms. You can use video, audio, pictorial, and graphs. So in the future, we're hoping to maximize the potential of this tool to include a water valve exercising program, a fire hydrant maintenance program, and a sanitary sewer survey, as well as street maintenance. So overall, with the Census AMI system in place, the City of Universal City has been able to take our conservation and work order management to the next level. Along with the SCADA system controls, AMI has allowed us to get a real-time picture on what is happening in our water production and distribution system. It has given us another tool to help conserve water and minimize non-revenue water. It also helps our customers save money and water by alerting them when constant use is detected on their meter, which is most usually a leak in the customer's home or irrigation system. The city has definitely been pleased with the results we've seen so far, and we would recommend it to other systems looking to accomplish the same. And that covers my end of the presentation. I think I've covered it pretty well. Thank you for your time, and I'll turn it back over to Travis.
Thank you, Travis and Avery, for a great presentation on reducing non-revenue water. This is a common issue for utilities, and I'm sure that the audience appreciated the leak detection strategies and available solutions to manage non-revenue water that were provided in order to ensure the health of the system is maintained. Now we're going to start the Q&A. We had quite a few questions that came in, so let's begin. I first wanted to address a question from a couple people where they were wondering, what does AMI stand for? And that means Advanced Metering Infrastructure. The first question is from Urema, and she is from Toronto, and she is asking, Travis, isn't it easier to prevent real losses from storage leaks by maintaining the equipment? I think it should be cheaper than solving the problem after it occurs, and also it reduces the loss of fresh water.
That's an excellent question. So I certainly would agree that a great methodology is to enlist a service plan associated with your storage tanks that includes all the maintenance associated with it. The question or the opportunity is to put some sort of monitoring device on those tanks that will let you to know when those systems have potentially failed or someone has done something that was unintentional and caused a leak or an overflow in those pieces, to give you a backup and feedback associated with it so that you're able to take action upon it quickly and capture that information instead of utilizing potentially a citizen to call in or alerting to a problem that it goes on for several hours during the non-working portions of the day, where we can certainly utilize both systems of a well-cited maintenance and asset improvement program as well as a monitoring program. I think would be the best approach going forward for most utilities. But an excellent question.
All right, our next question is for Travis again, from Tanya from the city of DeSoto. Does Census offer residential meters equipped with remote shutoff capabilities?
So that's an excellent question. We are in development process of residential meters with remote shutoff through an AMI system. Those products will be out in the 2016 timeframe. There are some other products available on the market as well for that service condition, but it will offer new abilities for each of the utilities to utilize new cost savings measures and to reduce any collection activities associated with it, as well as provide the utilities a way to save labor, and that labor can be redeployed for new leak detection as well as repair of those leaks. So I think it's an exciting time going forward for all utilities to look at those kinds of products. Thank you.
All right, our next question is from Mr. Galindo, and he is wondering, in what cases would you have an unbilled meter? And I think this is probably most suited for Travis.
Sure. Now, another excellent question regarding unbilled accounts. So if you were actually metering the utility services such as a city park or city hall to account for the actual consumption, but you may not be billing for those services as it's consumed by the city itself, it is important to distinguish all of the use and consumption within the water system so that you close your water balance appropriately, but they may be non-revenue water. It's just intended to be non-revenue water. The encouraging piece, though, is to make sure we account for all portions of both the inputs and the discharge to the system.
Great. Our next question is from Adele, and they're wondering, for water utilities without AMI, meaning advanced metering infrastructure, what is the period you recommend for calculating the water balance? All water meters are not read at the same time. It may add inaccuracies to the calculation, so I guess a short period of time for calculating the water balance may not be convenient. What do you think?
It's an excellent question as to how to account for the water in a system that is not serviced by an AMI infrastructure. It poses some new challenges. Certainly, the more frequently you can read those, moving to at very least minimum monthly billing and monthly recording of those flows gives you a sharper picture of what is being produced versus consumed, and possibly looking at isolating those through route management into district metering zones may help you account for the water usage associated with any routes in a AMR system deployment. We also would encourage the use of interval data there to track the portions of use over the periods of time that is recordable through that data collection process to look at produced water versus consumed and billed water.
Our next question is from Patricia for Avery, and they're wondering, did you find many leaks on customer service lines? If so, what percentage of leaks were found on the customer service lines?
We did have a number of leaks that were discovered. Well, what it was constant usage that was seen on the meters. I don't have a number of percentages on that, what that was, but we did have a number of instances where we were able to notify the customer that they had constant use on their meter, and they were able to rectify the problem and get it fixed. And most of them had no idea, because it would never manifest itself on the surface or in their home. But we did have occasions where we did have that. We were able to help the customer and notify them that they did have a leak of some sort.
Okay, our next question is from Christina, also for Avery. What was the cost to replace the 4,000 meters stated in the presentation?
I have the numbers, but I don't have. I can get back with you on the cost, but I don't have the cost here on that. I know our utility administration folks, when they were going through the purchasing part of it, they have that information, but we can get that if you'd like.
Thank you. Our next question is also for Avery from Alan in Montana. Do you prioritize leaks to determine which ones to pursue?
When we're using the logger system, we can tell what's called there's a range in the sound. You can tell by what the data that's transmitted, a weak signal or noise ratio to you can tell, but you can kind of tell. We're still working with that, but there's a way to tell through there what's this blasting sound coming through there's a range in there, and you can basically go through and pick and choose like that. What we usually do, though, we have our crews, and we will assign work orders using the Nova Center, and we'll have a gentleman that just go out. That's all they do. There's about 2 workers that we have, and they will go out and check through those. Usually, on average, we have about 5 or 6 locations every day that we need to check and verify. Some of those turn out to be either a misread or something interfering with the logger, and the ones that aren't, of course, we're able to take care of. But we just prioritize. Basically, we check every one that we have, and we go from there basically with that. If we discover that it's a major leak, of course, that gets the the priority, but we kind of rank them down from there and get to them as we can.
All right, our next question is from Jason, and this may be for both Travis and Avery or just one of you. They're wondering, how do you recommend testing the production meters at the wells?
Well, as far as Universal City goes, we're required by the Edwards Aquifer Authority to annually verify the accuracy of our production meters. I know we have Fluid Meter Service. They're out of Austin that checks ours, and they actually come out and do that for us. Usually, I mean, we're happy because between having 98 to about 100.1 accuracy on all of our production meters. But I mean, we have an outside entity that comes and does it for us.
And just to add to that particular comment from Avery, there are field meter test kits available where you can perform actual field testing of a meter through the flow ranges to determine its accuracy. And in some of those meters, they can be corrected electronically on site. Other meters would need to require either repair or replacement, depending on the type and the service condition associated with that meter. But there are opportunities to do field testing to verify the accuracy of those meters, and we would encourage all utilities, particularly around those large meters, to start a testing program as a significant portion of the water balance flowing through them, either in the production side or on the consumption side.
Next question is from Ralph in Alberta, Canada, and this is for Avery. He's wondering, what is the end user's price of water in Universal City?
Let's see. We have our rate structure is actually conservation geared. We have blocks, the structure in blocks per 1,000 gallons. It increases basically the more you use, the more you pay per 1,000 gallon. I can shoot you over. It's a bit complex, but I can shoot that over to you if you'd like to. Just send me your email address and your information. I can get you that. But it's part of our conservation program. It's year-round, basically the conservation pricing on our water, and it differentiates between residential, commercial use also. But if you like, I can send you that information, and I'm most happy to do that for you.
Wonderful. Our next question is from Maurice for Travis. Which census meters offer the automatic shutoff function?
The automatic shutoff function will be available in our residential meters. That will be in the 5/8, 3/4, and 1-inch line sizes, and it will be under the meter brand of Ally. So that product is due out in 2016.
All right, Ted has a question for Travis. Most of our system is looped in. That case, do you use bi-directional flow meters, or do you still install check valves? And if so, doesn't that reduce the reliability?
Certainly each distribution system is unique to the city and the municipality in which it was constructed. A great way to attack loops is try to isolate portions of them, either using district metering or virtual meters associated with the flow inside of each of those loops. And then you do need to account for the reverse and forward flow if there is any within a loop system. Most of the larger meters can detect both our flows in both directions to obtain forward and reverse flow and net metering flow between the balance of those two readings. And as you begin to look at those pieces versus the consumed piece, you can actually perform a water balance on each individual loop or a portion thereof of a loop. So it's an excellent question.
Our next question is from Mark for Avery. Did you implement AMI on your production meters? And if so, did you notice any increase in accuracy or decrease in water losses?
The AMI we don't use for our production meters. We do monitor that through our SCADA system, but we don't monitor production through AMI at this time. But we do a actual physical reading every morning in addition to our telemetry tracking. So I don't know if that answers the whole question for him or not.
That was great. Our next question is from Willie, and he is wondering what is the cost associated with the loggers? And this might be suited for both Travis and Avery or just one of you.
At the time when we were, yeah, go ahead, Travis. Did you want that?
So the loggers are frequently available for distribution activities around the country, so we would encourage you to get the associated price from those activities. But they're in the range of a couple $100 per logger activity going forward, and then you can deploy them within a typical network fairly easily as they work within a FlexNet AMI system. It's already been adapted to retrieve that data, broadcast it, and put the analytics within the system, whether you have the loggers or not. And if Avery, if there's additional pieces or data points you'd like to share, feel free.
Yeah, I mean, when we budgeted for everything, of course, we had the budget for the logger and the transceiver, or the radio transmitter on there also. One thing we did have to take into account, we didn't initially, were the valve stack lids. Most of ours are cast iron, and they did not get a very good signal out of those. And what we wound up having to do was drill holes through the or cut holes to these valve cap lids and place the antenna through there. Initially it took a little time, but there was just one unseen thing that we came across that was, it added a little bit of cost to the project, just because we did a lot of it in-house in our maintenance shop. But that was one thing that crept up on us. That was just we never thought about how we were going to get the signal out. So that's one thing to think about as well.
We have a question from John for Avery. How common is it for customers to tamper with their meters?
It's, I don't want to say it's real common. I know that we have pin locks, and it's more than one occasion we have people sawing off the ears on the curb stop to pop that off. But with the AMI, I mean, we're able to tell, who's been using water after they've been officially turned off. So it's kind of hard to hide from that.
Our next question is from Fred from Tucson Water, and this might be for both Avery and Travis. Why is system security not a top step to reducing non-revenue water? Tucson Water has significantly reduced NRW through the installation of fire hydrant locks to combat unauthorized usage.
So I think that's an excellent plan, and as we looked at the water balance earlier, certainly the utilization of fire hydrant monitoring within an AMI system for awareness, coupled with either preventive systems such as locks or maintaining systems, is encouraged. The lock is certainly a valuable deterrent. We would also indicate or solicit to the group that in addition to a lock that provides deterrence, there's the ability to monitor and gain awareness to when the lock has been defeated. So I think both plans going forward are good avenues and strategies for utilities to utilize to counteract any unauthorized use through a hydrant or any other metering service connection that might be available to someone trying to obtain water that shouldn't. Good question.
Next, we have a question from Deirdre for Avery. How do you notify customers of a continuous or intermittent leak?
I know we actually do a in-person consultation at first. We'll send a meter tech over once we get notification of a constant flow for constant use and actually look to see if we can go out there first to check, make sure everything's okay with the meter, and then if we go from there, if you can see water coming out somewhere, we'll notify the customer. If we can't, we'll just let the customer know, hey, we're getting constant use, showing on your meter. You might check into this. Have you checked? Do you have your washer running? If we can't contact them personally, a lot of folks have their email notifications set up, and they'll notify them that way also.
Josh has a question for Travis. Does the Sensus Permalog software and hardware support correlation of the possible leak location between two devices?
It does, so that you can utilize the two devices to bring in and map that through an AMI system to get GIS locations of there. And then certainly you may use additional field monitoring to pinpoint it, but through the AMI system you can get a high degree of awareness in a specific area, and then actually traveling down a distribution service connection or main to pinpoint exactly where to dig would be an accessory to the Permalog system.
Yeah, just to touch on that, we do use a correlator in conjunction with our Permaloggers to get a fine pinpoint as much as we can where this leak may be, and we do use that also in addition to the loggers.
All right, so our last question is that we have time for is from Steve, and this might be for both of you. How can this be used in multifamily housing leak detection?
Well, at least in Universal City, we don't sub-meter. Some of our multifamily locations, we could probably, it's hard to tell though. Also with constant use, because folks are up at different times, and but I don't know. I mean, because we don't sub-meter, that would be a little difficult, I think, on some of the multifamily units, at least for Universal City.
I think, Avery, you hit on the point there in terms of finding leaks after the meter at a multi-family dwelling. The only way to attribute it where it might be further downstream would be in a sub-metering activity. You can then utilize a common meter as sort of a net meter going into those opportunities if you had a suspected leak within a multi-tenant application to get more granular from where the leak might be or how it's being consumed. But that would be the best strategy going forward, would be to deploy additional data collection devices. Great question.
Okay, so this concludes the Q&A portion for this webinar. We will get to any remaining questions that were not addressed within the next 3 business weeks. Thank you again to our panel for addressing the audience's questions and for an enlightening session on non-revenue water. That concludes our webinar on the top 3 steps to reducing non-revenue water. On behalf of AWWA, I want to thank you for joining the webinar today. Don't forget to participate in the survey immediately following the webinar. Until next time, thank you for keeping the water safe and secure.